So let's talk through how we can use some of the new products, the M3E 4 Enterprise, as well as some of the other products that you guys may already have, such as the Mavic 3 Enterprise, the M300, M350, the P1, the L2. How are you going to be able to use any drone or any sensor that you have on the DJI Enterprise market and create and capture better 3D digital twins? So when we first start talking about mission planning, there is a lot that goes into mission planning. First off, you need to understand the output, and we're going to be talking about understanding the output. These are the main questions that you should really be asking yourself before you go out and capture or even plan a mission. The first one, does this capture require 2D or 3D? Are we surveying or are we capturing a digital twin three-dimensionally? 2D is very simple. We've been doing it now for over a decade of being able to create area routes and scan. But with 3D, that's what we're focusing on today. Does this include the entire asset, or are you really just looking at a specific part of the asset? That's going to help out dramatically when it comes to capture time. If you're trying to capture an entire industrial complex, it's like trying to drain the ocean at times if you're looking at really high resolution data. So be honest with yourself. What is the important part of the asset that you want to capture? And if it is the entirety of the asset, then how does that go into ground sampling distance? I think that's a little bit farther down here. So what resolution do you need? Do you really need millimeter resolution data, or do you truly just need centimeter resolution? And that's going to help speed up data capture. Another one is going to be, how are you analyzing the data? There are plenty of workflows that are either, one, you're doing the analysis on the 3D model, which means you need to build a good enough point cloud, mesh, or texture, or all three to do the analysis. Or are you just going to be utilizing the photos, the raw photos, running them through a pipeline to do AI detection for cracks or for leaks? If that's the case, then you don't need the overlap coverage to build a really high fidelity 3D model, and that means that you can capture faster. It's all about the speed and the efficiency of capture. Data size limitations. Also, when you're talking about GSD, you really need to understand, how am I going to be delivering this data? You can capture the best 3D model out there, but if it's a 12 gigabyte data set and their software that they're trying to utilize can only support data sets up to 100 megabytes, it doesn't really matter how good the data is, you're not going to be able to use it. So understand what software your customer, if you're a drone service provider, or your internal software, if you are the client, what software you're trying to get this data into to help build the flight plan. Lots of information here. I copied it from a white paper that I'm going to be posting later in the month. But when you start to understand your mission, you have all these different topics. This is understanding what the asset looks like. What is the asset size? What is the asset shape? How much time is allotted for data capture? Once again, if you only have 2 hours over a lunch break on a construction site to drain the ocean to be able to capture the entire site with millimeter GSD, it's not possible. So be realistic with how much time you have on site to understand what type of outputs you're going to have. Processing power, that's a good understanding too. So when we get on site, do we have internet connectivity? Are we going to be able to pull corrections through Ntrip, or are we going to be setting up our own base station? When we have processing power, if we're building three-dimensional flight plans, typically we are doing that on a 3D model that we just captured of the site, a very quick, rough 3D model. So to generate that 3D model, are you going to be utilizing the cloud? Are you going to have connectivity on site? Do you need to use your own computer to process that 3D model to then build a flight plan? Let's get into asset shape a little bit more, because I think it's kind of an art, kind of a science, and it's a little bit hard to understand. But once you understand what the tools we have, you dive in more. So what does Child's building blocks mean about capturing digital twins? How are they related? Well, it's understanding the geometry. If we can take an asset, simplify the geometry into building blocks, then we can start building flight plans for the different faces of this asset. So if we have a church, that's what we're going to be walking through today and in the white paper. Let's break it down into kids' building blocks, and now we can start building some of the flight plans for it. All we do is we start a new slope route mission. We then fly in front of that slope, and we're going to press the C1 button on the back of the controller. It's going to drop an AR view on the field, the FPV view, or you can go and look at that manual photo, and then we can build or drag the polygon and make it over the slope. You're going to get this view in AR view as well. So the very first thing that I do once I've built that area is I'm going to fly off to the side of that slope. That way I can understand if I have that slope at the right depth. So as you can see, I captured the C1 when the gimbal was all the way straight up. So now my slope is straight up. I can then adjust the mapping area and really position that slope mission directly over the facade that we need to capture. You can do this to all of the sides of the church and then just kind of queue up all of these missions. I might just keep it in this view because we have a lot of different videos. The next one's going to be geometric route. When we think of the child's building blocks, now it's automating more than one slope at a time. You're going to be able to orbit around or go around the entire asset, basically stacking a bunch of slope missions together. This is going to be really beneficial when we're trying to capture entire buildings if we need to. The workflow is, first off, I highly recommend, if you're doing this in Flight Hub 2, which we're happy to give you guys free trials of to test this out, you're going to build a 3D model when you first get to the site. So I flew over this Iowa skyscraper. It's about 12 stories tall, but that's skyscraper in Iowa. I flew over it with a smart oblique mission. So the gimbal is moving around, capturing a bunch of imagery for me. I'm flying above it, and it's just a quick 3-minute mission. I then process that 3D model in Flight Hub 2, and it turns it around probably about 20 or 30 minutes later. But once I have that 3D model, whether it's at the office or even just at the site, you can then build that 3-dimensional polyagonal blue area over where you need to capture. You're going to be able to set the bottom, set the top, and then set around it basically via pillars. And the key is, you can make as many of these missions as you want, and then you can start stacking them together. This is a model that I was able to create in Iowa as well. But it's such a complex structure, it's pretty hard to break it down into that kid's building blocks. But I was able to plan the top section, the middle section, and the bottom section. And then since I have all those flight routes already built, when the top one's done, the drone will just sit there and hover, and then I'll go ahead and just queue in the second mission. It'll go to the starting waypoint and start spiraling around, and then I'll queue in the third mission as well. So you can build multiple geometric missions, multiple slope missions to fully cover your asset. Geometric routes are also supported in Pilot 2. So the workflow we just went through was fly over the site, process the data, most likely go back another time and fly it. If you need to capture this data and make a geometric mission and you only have 30 minutes to capture the data, you can do that in Pilot 2. The workflow is on the satellite view, you will make a polygon over the asset that you want to capture. It's going to show in AR view on Pilot 2 where those pillars are. So as you move it around in the satellite view, those pillars are going to change. So if you have a building, you just need to set them over the pillars, and now you have the boundary of your asset made for geometric. The last step is going to be flying to the bottom of it, pressing C1, flying to the top of it, pressing C2, and now we've built that 3-dimensional polygon to build a flight plan from. Now, All of that kind of sounds complicated. Who here would like that just to be easy buttoned? Because we did that earlier this year with the Smart 3D Capture and the M4. So with the onboard improvement processing of the controller, as well as on the drone, and the improved obstacle avoidance, now we're going to be able to fly over the site, quickly process the data, whether it's a point cloud on the Pilot 2 app, or you're processing it in Terra or Flight Hub 2, or even a third-party software to import in a 3D model. All you have to do is click around the asset, and boom, there's the easy button. We build that three-dimensional flight plan for you, and it becomes very complex. It's not just a bunch of slopes or geometric missions stacked together. That being said, with the right art, because how many of you have an M4 already? Oh, okay, all right. How many here are flying an M3E? There we go. So that's why I want to make sure, while Smart 3D is the easy button, let's learn the basics and really get into understanding a geometric mission, a slope mission, because you can get just as good data from an M3E and these types of slope missions, or these types of missions, as the Smart Capture with the M4. It just takes a little bit more work. So the Smart 3D Capture, first off, you're going to build that rough 3D model like we talked about before. We generally are aiming for 400 photos or less, but it's going to be a very quick flight just to build that point cloud for you. From there, I can then start my flight route planning by creating a route, and now we have the new Smart 3D Capture. I'm going to select the 3D model that we processed on the controller within a couple minutes, depending on the data size, and now I just need to select around where I'm capturing, and much like we saw on the last screen with Flight Hub 2 doing it, now it's going to build our flight plan for it. And it's just like a normal mapping mission at this point. We're setting our GSD, we're setting our mapping speed, we're setting our side lap, we're setting our front laps. And boom, it's automated. But the beauty of it, the true beauty of it, is with the M4E, we now can capture and move the gimbal up, down, and left and right. So instead of having to capture all the different axes of this asset, as you saw at the very first screen, it's doing it all at once. So now you can just spiral all the way down the asset three-dimensionally, and it's going to capture your x-axis, your y-axis, and your z-axis all at the same time. Way faster of a workflow. But this is simple. We kind of lose the art when we have it be so simple. At the very end of your Smart 3D Capture flight, you do get a processing report. From here, we get overlap, or we can see what the overlap is three-dimensionally of the asset. So if there was an area that you missed, you can go back in there with manual photos, capture that, and when you go to process the data, throw those manual photos in there, and then you'll have a better 3D model. The last flight plan that we're talking about is not actually one that you plan in the area or the flight route area of Pilot 2. These are point of interest orbits. Very, very fast, and it's a 95% automated mission. If I just need to spiral down an asset and capture imagery, I can. It's very similar to a geometric mission if you're doing the cylinder version of a geometric, but it's much faster. It works wonders on cell towers when you're talking about the workflow. So all you have to do to start a point of interest orbit is you will set one of these blue pins over the asset. You'll fly directly over the center and set a blue pin. One question we typically get is, if I'm doing flare stacks, I don't want to fly directly over this. Well, we have our 7x zoom camera. I could fly 200 feet over the asset, use the 7x zoom, get right over the dead center, and then drop a pin. Once I have my pin dropped, you're going to see the orbit option show up. I'm going to back off of the asset. I'm going to select the point of interest orbit, and now we have our POI menu. I'm going to then take my right stick and move it left or right, and it's going to start orbiting. If I press C1, now hands off the sticks. This drone is flying freely and just going to keep orbiting until you tell it to stop. I'm going to go ahead and set my time lapse. What's the fastest trigger speed that you're setting on an M3E? What's the trigger speed? 0.5s with the M4E. Great, bonus points. What's the M3E? 0.7. So you're triggering every 0.7 seconds, and all you have to do once you set up that point of interest is just you make an orbit, you drop your altitude, you take the left stick and you move it down a little bit. It's not totally automated, but if you get this workflow down, it's actually very simple of just fly over it, grab a point, back off of it, start orbiting, start capturing the panorama. I can honestly make a really good 3D model of a cell tower with the M3E in like 11 minutes and flight planning is very, very simple. So really start utilizing those other flight plans. There are some others here. You can see what is supported in Pilot 2 as well as Flight Hub 2 based off of the drone that you have. Some of these boxes that are not checked in, like if you are trying to do a slope or a geometric style mission, but you're using a bigger bird like the M300 or M350, that's where there are some third-party flight softwares that's going to be able to automate that for you. Just we don't have any solution at this point. Let's get back into it. How do we capture this church? Well, in my opinion, which there's a lot of opinions out there, I would love to hear your feedback, but I see if I'm capturing it with the M3E and I'm doing it with my head instead of smart 3D capture, I really see that I have two options. One, a geometric mission across the entire asset, all the way up until the church's spiral. Then from there, I'm going to grab a point of interest orbit. But when I'm capturing these geometrics, I'm not following the face of the roof. So I need to go back in and grab these slopes to be able to stay the even GSD across the entire asset. You don't have to do this, but you're going to be farther away from the roof here, so your GSD is going to go down. Or you can do it with a bunch of slope routes, and you're going to not have to do, this is going to be much more automated, but you're going to have extra imagery here. This is going to have all of the imagery that you really need, but you're going to have to be planning slope routes across all of them. And then one final point of interest orbit. So you can see some of the reasonings for process one, less flight plans required. You're also going to have more hands off the stick time because I'm flying manually in between these missions. Whereas here, I have less missions. But two, you don't have to have that wasted imagery. So let's talk about data capture. First off, definitely, sorry for being loud, definitely check obstacles when you're on site. While there are improvements on the M3E and the M4E for obstacle avoidance, and seeing those when you're in winterized trees, power lines, thin structures, don't just assume that the obstacle avoidance is going to work. And I don't care what drone you're flying from what manufacturer, don't assume that the obstacle avoidance is always going to work. Also, what I would recommend doing is in the obstacle avoidance menu in Pilot 2 is you're going to set your mode. You have brake, avoid, and off. Don't set it to off, leave it on because you're flying very close to the asset. Slope missions, geometric missions with the M3E, you can fly down to 3 meters away from the asset, getting you sub-millimeter GSD. With the Smart 3D capture, you're flying down to 1 meter away from the asset, giving you 0.3 millimeter GSD imagery. So you're flying very close. You need to have obstacle avoidance on. You can have it just brake, or I recommend setting it to avoid. That way it can somewhat maneuver around an asset if it sees it or an obstacle to make sure that it stays on the flight plan. Also, you're going to get all of these green flight plans in the AR view when you load them up in Pilot 2. So when I load them up, I generally just do a quick look. Okay, looks like the green flight plan line isn't going to run into anything, and I'm good to go. The camera settings, that is a whole nother topic that I'm not going to dive into right now, but I do recommend highest shutter speed possible, making sure that you're having your focus setting, AFS, AFC, or manual focus. That is becoming a little bit more challenging because we are so close to the asset. You don't want to just set it to the full landscape, full like infinity depth, you actually start to need to have it on AFS or AFC. Battery life, obviously another thing to consider. Adding in those extra manual photos if needed, you can always add those in and process data. Flying between the missions. If you have like 6 or 7 slope missions and you plan one and you don't plan ahead and you finish the one on the one side of the building and you hit go and it's for the other one for the other side of the building, it's gonna have a hard time getting up and around. So honestly, I'm at the point where I will load in the next mission when I am done. I see where the green AR lines are and I will fly it close to the start point and then hit go. Also, when you're planning these geometric missions, what is one of the rules that the FAA mandates that we must do while we're flying our drone? What do we gotta do? Maintain line of sight. So if we're building a flight plan building it over a building, and I'm orbiting around it, if I'm standing in one spot and I have it set to horizontal, it may be the most efficient data capture, but it's going around behind the building and you're losing it every single time. You're probably gonna be fine, but legally, that's not technically right. So you have the ability to set a geometric mission to capture either horizontally or vertically. So as you're capturing, you can walk around the building with the drone as it's scanning up and down and you never lose line of sight. Just another safety tip. There's also those third-party capture apps, UGCS, Drone Deploy, a lot of them that automate some other captures if you need to. Two of the other improvements that I have seen, one is the view out of the obstacle avoidance sensor. When I'm flying these geometric missions, it's not uncommon for me to be viewing out of that sensor more than I'm viewing out of the camera. I can see that when I switch it, I'm still able to see with the small screen that I am still capturing good data. But at least now I know if I'm coming up on any sort of obstacle that I might be coming close to. And finally, camera settings. We got to tout. Having a good camera is a pretty important part of creating a good digital twin. So with the M4E and the M3E, having that 4/3 inch sensor, 20 megapixels, having more of a dynamic range, it's going to allow us to capture in more uneven lighting conditions and still have a very flat 3D model where it doesn't look like one side has a bunch of shadows on it or one side looks more blue because you're flying it later at night and you just have less light getting into the sensor. So having a larger sensor is going to be able to help out just create a more even digital twin reconstruction. That is a mind dump of digital twin creation. I am planning on having all of this in a comprehensive white paper that I grabbed most of this information from already. And if any of you guys have questions, I'll be sticking around the booth. So thank you all for stopping and listening in.